Let's look at question 29. We want to rationalize the denominators. Sometimes we do rationalize the numerator. So later on, when you learn calculus, when you deal with the difference or quotient, sometimes we rationalize the numerator. Okay, what does it mean, rationalize? Remember numbers like this, right? Square root of 7, square root of 2, square root of 5, they are irrational numbers. Irrational means, nobody really can make sense out of it. Like a 5 is a rational. Why is it rational? It makes sense to our brain. 5 people, 5 apples, right? Or square root of 5. Square root of 5, well, it's in between 2 and 3. We can approximate it by hitting in the calculators, right? It will give us approximation, but for its exact value, no one knows on Earth, at least. All right. So we call it irrational numbers. So rationalize means, a process to make the irrational numbers somehow to be a rational number. A rational number is a fraction. A numerator is an integer, denominator is an integer. So basically, we want to make the denominators, we want to get rid of the radical signs in the denominators. So how do we get rid of the radical signs for A? The index is 2, right? So we want to multiply by another square root of 70x in the denominator. Because we want to make 7x to be 7x squared. Then square and square root cancel out. Because 2 over 2 is 1. So we get 7x. But if we do that for denominator, we have to do the same thing for numerators. Right? You can understand as we're multiplying this expression by 1. And 1 is a transformer in mathematics. Right? It's a some expression divides itself. In this case, this 1 is square root of 7x divides by itself. By doing so, we get 1 times square root of 7x. We get square root of 7x in the numerator. And the denominator, we just have 7x, right? Because we have 7x square root. Okay, so the denominator in A is a monomial, one term. The difference of A and B is B, the denominator is a binomial, 2 terms. So we want to use something called difference difference of 2 squares formula. Different square formula is in A square or A plus B times A minus B. We call those 2 conjugates equals to A square minus B square. So A plus B and A minus B are conjugating each other. So we get A square minus B square. So just imagine if we have square root of A plus square root of B times square root of A minus square root of B, then we would get a square root of A square and square root of B square. Well, square and square root cancel each other. So we just get A minus B, right? You see? So this is a process of rationalize. We see the numbers from radical A, radical B change to be just A and B integers. So this process is called rationalize. So we want to multiply by the conjugate of 9 minus square root of 5, which is 9 plus square root of 5. And we'll do the same thing for the numerator. 9 plus square root of 5. Then the denominator, we don't really have to calculate it. We just use this expression, okay? Just use this expression. In this case, we have 9. So we have 9 squared. 9 squared is 81 plus square root of 5 squared, which is just, minus, not plus, minus. Later on, when we talk about difference of two squares with complex numbers, it becomes a difference of, becomes the sum of two squares because of the imaginary part. So 81 minus 5 in the denominator. And the numerator will have 5 times 9, and then plus 5 times radical 5. So we get a 45 plus 5 radical 5 in the numerator. And the denominator, we have 81 minus 5. What's 81 minus 5? 76. Right. So this is our answer. So now you see the denominator is rationalized because the denominator is 76, which is an integer. And we do have the radicals in the numerator now. So C is similar. We want to multiply by the conjugate of square root of 5 minus 3, which is square root of 5 plus square root of 3. We do the same for the numerator. Okay, allow me not to write it. Too hard to write it with my fingers. Then the denominator right away, we write as square root of 5 squared, which is just 5, minus square root of 3 squared, which is just 3. The numerator, we multiply 3 radical 10 with radical 5. We get a 15 radical 2. I leave you to calculate for yourself to see why. Then plus 3 square root of 30. And of course, 5 minus 3, that's just 2 in the denominator. Now let's see D. D, the index is 3 in the denominator. So I want to multiply under the cubic root sign. I need to multiply x squared to make the exponent of x to be 3. And I need to multiply y raised by first power also. So I need to do the same for the numerator. So under the cubic root sign, I need to multiply by x squared and y. You see, again, we just multiply by 1. Right, this 1 is a cubic root of x squared y divides itself. So once I do that, you see here, you see x times x squared becomes x cubed. Then with cubic root, I just have x. Then y squared times y, that's y cubed. With cubic root, that's just y. So the denominator has no more radical signs. And the numerator becomes xy times cubic root of 2x squared y. Now the denominator has no more radical signs, which is rationalized. Okay, allow me to erase this so I can move up. Okay, let's see E. Again, the denominator, I want to rationalize the denominator. So 9 is a 3 squared. I want to make a 3 cubed. So I want to multiply by 3. X is x squared, so I need to multiply by x. I'm going to do the same for the numerator. Again, when I simplify expressions, I can only multiply by 1. But 1 is a transformer. Is any expression divides itself. So now the numerator, I have cubic root of 7 times 3, which is 21x. The denominator now is being rationalized because 3 squared times 3, then cubic root, that's just 3. X squared times x, x cubed, then cubic root, that's just 3x. For this one, I need multiply x raised by, so I have x raised by 6 already. So I need to multiply x raised by 4 to make the exponent of x to be multiples of 5, because I'm dealing with the 5th root. The index is 5. So the power of x needs to be multiples of 5. So we already have x raised by 6. We need to multiply by x raised by 4. We do the same for the numerator. Now I have x raised by 10. Okay. X raised by 10, the 5th root, that's x squared. So the denominator is rationalized to be x squared. No more radical signs. And the numerator, I still have a 5th root of 7x raised by 4. Okay, now let's look at the 30. We're going to solve those radical equations. First, we want to single out the radical signs. So we want to move this negative 11 to the other side, become positive 11. Now we want to square both sides. Because the radical terms are by itself now, if we square root cancel each other. So we get a 6x plus 1 equals to 11 squared, which is 121. Then minus 1 on both sides. We'll move positive 1 to the right-hand side of 6x equal to 120. And divided by 6 on both sides. So x equals to 20. That's for A. For B, we want to do the same thing. We want to move this negative 1 term to the other side, become positive, right? So become positive. A square root of x plus 5 on this side now. Now we can square both sides. Let me change my color. So I square this side. I square this side. Square root cancel each other. So now I have x squared minus 15 equals to x plus 5. I square both sides, square root cancel each other. So I have this. I have a quadratic, right? I see x squared here. So I'm solving quadratic equations. For quadratic equations, we want to leave one side to be 0. We move all the term to the other side. So after we do that, we get x squared minus x minus 20 equals to 0. All right. This is the way how to solve quadratic equations. We always want to make one side to be 0. Doesn't matter to be left-hand side or right-hand side, you know. Now negative 20 can be factored. So we want to factor this into 2 factors, 2 binomials. So it can be factored as x minus 5 and x plus 4 equals to 0. Right? How do I factor this? I'm thinking about factors of negative 20, 2 factors. Multiply to be negative 20. That means one has to be plus, one has to be minus, right? Then this 2 adds up to be negative 1 because the number before negative x is negative 1. So that's negative 5 and 4, right? Because negative 5 times 4 is negative 20. Negative 5 plus 4, that's negative 1. So that's why I factored as x minus 5 and x plus 4. Then use 0 property. Seeing x minus 5 is 0, which means x equals to 5. And x plus 4 is 0, which means x equals to negative 4. So 2 solutions. But now with 2 solutions, usually we go back to check to see if they are truly solutions. Because once we square, sometimes it causes extraneous solutions. Okay, means not real solutions. But if we do check, we see 5 squared minus 15, that's square root 10. Then square root 5 plus 5, that's the square root 10 also. If we plug in -4 squared is 16, minus 15, that's 1. Then square root of -4 plus 5 is also square root of 1. So both solutions. So we have 2 solutions for B. Now let's see C. C, we want to combine positive 4 and 7. How do we combine? They're on 2 sides. They're not on the same side. So we need to move around. We move positive 4 to the other side, becomes -4. So which means 7 minus 4, we get 3. So now we want to raise to third power because the index is 3. So we want to raise to the power with the same number as the index. So once we raise to third power, we get 3x for the left-hand side. For the right-hand side, we have 3 raised by 3, which is 27. We divide by 3 on both sides, so x equals 9. So substitute x equals 9 into the equation. 3 times 9, 27. 27 cubed is 3. 3 plus 4, indeed 7. Okay, now let's see D. D is a little bit more work because we have a square twice. Let me make enough space. So first, I want to square both sides. Square both sides. And some people make mistakes in here by doing square each one on the right-hand side. No, you cannot do that. You have to square with the parentheses. This one, I don't put the parentheses. Why? Because they're all under one square root sign. Right? So I don't really have to put parentheses for the left-hand side. But for the right-hand side, I have 2 terms. I have this square root of x minus 3 as one term. I have positive 2 as another term. So I have a binomial kind. So when I square this, I need to put the parentheses. And this is called a perfect square. Right? Remember perfect square formula? Perfect square formula is saying A plus B squared equals to first term square, which is A squared, plus product of AB times 2, which is 2AB, then plus B squared. Right? If you try to memorize a couple times, you know, it's not so difficult. So in our case, what's A? This square root of x minus 3 is 8. 2 is our B, right? The left-hand side is pretty easy. Left-hand side just becomes x plus 2, x plus 5. So the right-hand side, I have to apply perfect square formula. So I get square root of x minus 3 squared, which is just x minus 3, plus 2 times 2, which is 4, times square root of x minus 3. So I'm going to write it with a pencil. So square root 4 times square root of x minus 3. Okay, and the square root. Then what else I have? I have 2 squared plus 2 squared, which is 4. By perfect square formula, right? So square root of x plus 5 just x plus 5. Square root of, so a squared square root of x minus 3 squared just x minus 3. Then 2 squared just 4. So the middle term comes multiply a and b, which is 2 radical square root of x minus 3. Then multiply by 2 again. So we get a 4 square root of x minus 3. Now we want to move everything to one side. We want to single out this term, this radical term. So we can square it, right? So we move 4 to the other side. We move -3 to the other side. Actually, we can combine. We can combine -3 with 4 to be 1. So we have x plus 1, right? We want to move x to the other side, well, x canceled, x minus x canceled. Then move 1 to the other side becomes negative. So 5 minus 1, just 4. So we have 4 equals to 4 radical x minus 3. So we want to simplify this equation. So we can divide it by 4 on both sides. When we divide by 4, we just get a 1 equals to square root of x minus 3. Now we're in a beautiful form. We want to square both sides. So we want to square this one. We want to square 1. So we get a 1 equals to x minus 3. Square root cancel each other. So x equals to 4 is our solution. Okay, for D. We plug in 4 to see, okay, 4 minus 3, that's 1, square root 1 plus 2, that's 3 on the right-hand side. On the left-hand side, we have 4 plus 5 is 9, square root 9 is also 3. Okay, now 31 is about complex numbers, right? So under square root radicals, under the square root, we have negative numbers now. So this is just 6i, right? Because square root of negative 1 is I. And 75 equals to 25 times 3. So that's 5 radical 3i. So 3 times 25 is 75, right? Okay, for 32, we want to perform indicator operations, could be plus, could be minus. Right? Basically, we're adding, subtracting, multiplying, dividing complex numbers in the a plus bi form. This I is defined as the square root of -1. Because in real number systems, right, any number multiplied by itself has to be non-negative, has to be at least 0. So we create another number system called imaginary number system, which means something squared, I squared, this I squared equals to -1. I squared equals to -1. Just to want to do the things that real numbers cannot do. Okay, now let me move to the next page. So let's add those complex numbers. So complex numbers has a real part, has imaginary part. The imaginary part is always multiplying by I. So when we add two complex numbers, we add a real with real. So a plus 2, which is just 10. Then we add a complex part with the imaginary part with imaginary part, which is 3i plus 7i, which is a 10i. So that's how we add two complex numbers. Well, let's see subtraction. Right, we do the same thing. 10 subtract 4, that's 6. -3i subtract the -6i, negative become positive. That becomes -3i plus 6i, which is positive 3i. So this becomes B6 plus 3i. Okay, we can multiply. So 3i is also a complex number, but the real part is just 0, right? So we distribute 3i to 4, we distribute 3i to -8i. What do we get? Let's write over here. 3 times 4, 12. So we get 12i. Then minus 3 times 8, 24. I times I is the same as x times x to be x squared. I times I is I squared. I squared, remember I squared equals -1. I squared is a very important number, right? Because it goes from imaginary number, it's a bridge in between imaginary number and real number. The right-hand side, -1 is a real number. but the I itself is imaginary number. So this is a bridge in between of imaginary system, number system, to real number system. So this I squared equals -1. -24 times -1 becomes positive 24. So usually we write the real part first, because A plus BI form. So we write the real part first. We write the imaginary part second. So our solution is 24 plus 12i. For D, we FOIL it. We have a binomial, we have a complex number times complex number. We can think as a binomial times binomial. So we do a smiling face, right? We multiply those two, we multiply those two, we multiply those two, we multiply those two. Happy face. So when we do that, we see we have 2 times 8. 2 times 8, 16. Then minus 9i times 3i. 9 times 3, 27. So get -27. Then I squared is -1. -27 times -1 becomes plus 27. So you see the top part give us a real number, real part, right? One is 16, one is 27. We just add those two. When we add those two, what do we get? So we're doing the second step. Now we multiply under. So -9i times 8. So that's minus 72i. Then 2 times 3i, that's a 6i. So 72, let's do one more step. So 16 plus 27, 7 plus 6, we get 13. We get a 43, the real part. And imaginary part, we have a 72, -72 plus 6, which means is 72 minus 6, but with a negative sign. 72 minus 6, which is 66. So minus 66i. So the real part is 43. The imaginary part is -66. That's for D. For E, we're dividing two binomials. We're going to use the difference of two squares formula again. All right. But with complex numbers, it's called difference of two sums. Let me write on the side. Not difference of two sums, sum of two squares, sum of two squares. Okay, so how do we write that? So we have A plus BI times A minus BI, right? That equals to A squared minus B squared I squared. Remember, I squared is -1. So that I squared -1, changing -b squared to be plus b squared. Okay, so in complex world, the difference of two squares becomes the sum of two squares. So with complex number systems. So we're going to use this one for this, because you see, this changes complex numbers to real numbers, no more I on the right-hand side. Okay, so we do that. We multiply by its conjugate, which is 2 plus 5i. We do the same for the numerators. Multiply by 2 plus 5i. And right away, we don't really need to calculate. We just apply the formula, all right? So we get a squared in our case is 2 squared, which is 4, plus the imaginary part 5 squared, which is 25. And the numerator we have, the real part we have 3 times 2, 6. Then we have 2i times 5i. We're both positive, so we get a plus 10i squared. Well, I squared is -1, so that becomes minus 10. So the real part we get a -4, because 6 minus 10, that's -4. And the complex part comes from this down multiplication. 2 times 2i is 4i. 3 times 5i, 15i. 15i plus 4i, that's plus 19i. Then the denominator 4 plus 25, this is 29. But if we want to write it in a plus bi form, because that's the real part and imaginary part. So the real part in this case is negative 4 over 29. And then the imaginary part is positive 19 divided by 29i. I indicates this one is imaginary part. So similarly for f, we want to multiply by the conjugate of 4 plus 2i. We multiply by 4 minus 2i. We do the same for the numerators. 4 minus 2i. Then when we multiply, so when we multiply binomial, let's put the parentheses around. Okay. And the right away, the denominator, we get a squared, which is 4 squared, 16, plus 2 squared, which is plus 4, which is just 20. So the denominator is 20. Well, then negative 5i times 4, that's negative 20i. Then negative 5i times negative 2i. Negative times negative become positive, so I have 10i squared. Positive 10i squared, but I squared is negative 1, so that becomes minus 10. We can simplify. So we just get a negative I minus half. But usually we write the real part first. So we would write negative half minus I. So that means the imaginary part is just negative 1. Let's see what else we have. Oh, we finished. So we have finished. I hope this helps. And good luck for your exam.